Langchain OpenAI embeddings. A comprehensive explanation of langchain OpenAI embeddings. A powerful tool that leverages OpenAI's embedding models to convert text data into numerical representations. This process enables various NLP tasks like finding semantically similar documents and uncovering deeper text insights. Inputs. Text refers to any textual content, be it a paragraph, a sentence, or even a single word. This input is fed into the embedding model for processing. Document. A complete textual document, potentially containing multiple paragraphs or sections. This could be a news article, a book chapter, or any structured text data. Outputs. Embeddings. The numerical representations generated by the embedding model. These embeddings capture the semantic essence of the input text, allowing for various NLP applications. Steps. Input processing. The provided text or document is passed to the selected embedding model. This initiates the conversion process. Embedding generation. The model analyzes the input, considering the semantic relationships between words and phrases. It then generates a numerical vector, known as the embedding, that encapsulates the input's meaning. Prerequisites. OpenAI Application Programming Interface. Key and essential requirement for accessing OpenAI's embedding models. This API key acts as your authorization credential for interacting with OpenAI's services. OpenAI embedding model. You must choose an appropriate embedding model from OpenAI's repertoire. These models vary in their capabilities, size, and performance characteristics, so selecting the right one depends on your specific use case and resource constraints. Fine-tune parameters. Dimension determines the length of the generated embedding vector. This parameter directly influences the model's ability to capture complex semantic nuances, with higher dimensions potentially representing more intricate relationships. Model. The specific OpenAI embedding model to be utilized. This selection depends on factors such as desired accuracy, speed, and computational resources. OpenAI offers a range of models with varying characteristics. Challenges and fixes. Challenge 1. The generated embeddings might not fully capture the intended semantic meaning of a input. This can happen due to the inherent complexity of language and the limitations of any embedding model. Fix 1. To mitigate this challenge, you can explore using different embedding models. Adjust the model's parameters to fine-tune its behavior, or pre-process the input text to improve its clarity and remove potential ambiguity. For instance, you might remove stop words, common words like a, and or apply stemming, reducing words to their base form to enhance the embedding process. Challenge 2. The embedding model might demand significant computational resources, potentially slowing down your application or exceeding available capacity. This is particularly relevant for large-scale NLP tasks involving vast amounts of text. Fix 2. To optimize the embedding process, consider batching inputs to process multiple pieces of text together. This can improve efficiency by reducing the number of individual requests to the model. Alternatively, you can choose a smaller model, which might compromise on accuracy but significantly reduce resource demands. Reducing the embedding dimension can also lead to computational savings. Base OpenAI LLM Summary. A base class representing OpenAI-based large language models (LLMs) within the langchain framework. Inputs. Text that serves as input for the LLM, providing context and information for the model to process. For example, this could be a question, a prompt, or a piece of text to summarize. Outputs. Text generated by the LLM based on the provided input. The output could be a response to a question, a summary of the input text, or creative content generated by the model. Steps. Establish a connection to the OpenAI Application Programming Interface API by initializing an OpenAI client. This involves setting up authentication and configuring the connection parameters. Send a request to the OpenAI API using the provided text as input. This request includes the model to use, the desired output format, and any relevant parameters. Process and return the response received from the OpenAI API. This involves parsing the response data, formatting it as needed, and returning it to the user. Prerequisites. A valid OpenAI API key is required to access the OpenAI API and utilize its capabilities. This key is used for authentication and billing purposes. This is an example of a secret key used for accessing the OpenAI API. It is a unique identifier for your account. An OpenAI API client is necessary to interact with the API. This client provides functions and methods for making requests to the API, handling responses, and managing the connection. This is a Python library that provides a convenient way to interact with the OpenAI API. Fine-tune parameters. A parameter that controls the randomness of the generated text. Higher values result in more creative and surprising responses, while lower values produce more predictable outputs. A parameter that limits the maximum number of tokens the model can generate in response to a prompt. This helps to control the length of the output and prevent excessive generation. A parameter that controls the diversity of the generated text by sampling from the top p most likely tokens. Lower values focus on the most likely tokens, while higher values allow for more variety. A parameter that penalizes the model for using the same tokens too frequently in the output. This helps to avoid repetitive phrases and encourage more diverse language. A parameter that penalizes the model for using tokens that have already appeared in the input text. This encourages the model to generate new and creative content rather than simply repeating the input. Challenges and fixes. The OpenAI API has rate limits in place to prevent abuse and ensure fair access for all users. Exceeding these limits can result in throttling or temporary blocks. This library provides functionality for automatically retrying requests in case of rate limiting, helping to handle these scenarios gracefully. The OpenAI API can return errors due to various reasons, such as invalid input, exceeding usage quotas, or server issues. This code structure allows for capturing and handling potential errors from the OpenAI API, providing error messages and appropriate actions based on the error type. Managing the number of tokens used in requests is crucial to avoid exceeding usage limits and ensure cost effectiveness. This parameter helps to control the length of the generated response and optimize token usage. Fine-tuning the model for specific tasks can improve its performance and make it more suitable for particular applications. The OpenAI API provides tools and methods for fine-tuning models on specific datasets, allowing you to customize the model for your specific needs. Langchain OpenAI LLMs base OpenAI. This class serves as the foundation for utilizing OpenAI-based language models within langchain framework. It lays the groundwork for interacting with the OpenAI Application Programming Interface API to leverage their powerful language models. Inputs. The text input to the OpenAI model, which is expected to be processed by the model. Outputs. The output generated by the OpenAI model after processing the input text. Steps. The first step involves setting up the connection to the OpenAI model. This typically involves instantiating an OpenAI model object and configuring it with necessary parameters like the specific model to use, e.g., GPT 3.5, GPT-4, The input text is then sent to the initialized OpenAI model. This is a critical step where the model receives the information it needs to perform its task. The model, having processed the input, returns the generated text as output. This output might be a response to a prompt, a summary of the input text, or a creative piece of content depending on the chosen model and the input provided. Prerequisites. An OpenAI API key is essential for interacting with the OpenAI API. It serves as a credential to authenticate your requests and grant access to the OpenAI models. You can obtain your API key from the OpenAI website. This is a unique alphanumeric string provided by OpenAI that acts as your identification for accessing the API. It's a crucial component for any application that wants to use OpenAI's services. An OpenAI API client library or framework is needed to handle the communication between your application and the OpenAI API. These libraries abstract away the complexities of making API calls and provide a convenient interface for working with the API. This refers to software libraries that provide pre-written functions and tools for interacting with the OpenAI Application Programming Interface API. These libraries simplify the process of sending requests to OpenAI and handling their responses, saving developers time and effort. Fine-tune parameters. The specific OpenAI model to use. This determines the capabilities and characteristics of the language model. Common choices include GPT 3.5, GPT-4, and other specialized models. This parameter controls the degree of randomness in the model's output. A higher temperature value leads to more unpredictable and creative outputs, while a lower value results in more deterministic responses. This parameter limits the maximum number of tokens the model can generate in a single output. Tokens are the basic units of text in a language model, and this parameter helps control the length of the generated text. This parameter controls the model's tendency to sample from the most probable words. A higher top p-value increases the diversity of the generated text, while a lower value makes the output more focused on the most likely words. This parameter encourages the model to generate text that is less repetitive by penalizing the use of words that have already been used frequently in the output. This parameter encourages the model to generate text that is less predictable by penalizing the use of words that have already appeared in the input text. Challenges and fixes. The OpenAI API has usage limits in place to prevent abuse and ensure fair access for all users. These limits can be encountered if your application makes too many requests in a short period. To address rate limiting, you can use a rate limiter library to throttle your requests or implement a retry mechanism that waits for a short time before sending a request again if it's rejected due to rate limiting. The OpenAI API might return errors due to various reasons, such as incorrect API keys, invalid requests, or temporary server issues. It is crucial to handle these errors gracefully. This can involve retrying the request after a short delay, using a different model, or providing informative feedback to the user. The OpenAI models have a limit on the number of tokens, words, or subwords they can process at once. This can become an issue when dealing with large amounts of text. One approach is to split the text into smaller chunks that fit within the token limit and process them individually. Alternatively, you can choose a model with a high token limit if possible.